Hello, I'm Ryan from Growthbook, and I'm joined today by our head of data science, Luke Sonnet. Hey, Luke.
Hey, Ryan, how's it going?
Good. We are going to talk today about the experiment decision framework. We usually refer to it as EDF. Tell us a little bit about what the experiment decision framework is, what problem it solves.
Sure, yeah. The experiment decision framework is a set of tools to basically help reduce friction in experiment decision making, help you know what to do next in a given experiment, and kind of provide clarity around what your priorities are as an organization when it comes to shipping an experiment and how those should lead to decisions when you're ready to wrap up an experiment or figure out what to do next.
Thanks. So my kind of take, my naive take, I guess, is that when you're running an experiment and you get kind of stat sig, like it should be very clear about what to do next. But I guess the realities of it, when you start having lots of different things you're trying to measure, things can get complicated. Is that kind of what you're talking about when you're doing real testing on a real team with lots of different kind of competing things, you need a little bit of help?
Yeah, I'd say there's kinds of a couple different issues that can come into play there. One is, and I think we'll talk about this a little bit later, is that if you just choose to ship things whenever they cross a stat sig threshold, unless you're using something like our sequential engine, you can end up really inflating your false positive rate, and you'll end up shipping a lot of things prematurely. And so one of the tools in the decision framework is to instead say a decision is reached when you have a certain amount of data or precision in your experiment, as opposed to just when it crosses stat sig. So that can help kind of improve the experiment practice at your organization, at your company, and keep decision making tied to statistically grounded principles like precision and sample size, rather than as soon as something crosses into stat sig. The other case is, maybe things aren't so clear in your results, or maybe your company is in a situation where you want to run a test to make sure you're not making things worse instead of making things better. So in that case, you might have a few kind of null goal metrics, but with the decision framework, you can kind of say, hey, as long as we've gotten this much data in and nothing's being harmed, we can render a kind of ship now decision. So that's the kind of decision making you can put into place with the decision framework and kind of empower experimenters to just say, oh, my company or this default has told me this is the kind of decision I should be making in this situation. And it can reduce that friction of that person going, wait, what am I supposed to do now?
Yeah. That I can see how that can be helpful. Let's jump in and kind of show more concretely how this is all playing out. So Luke's going to share his screen here and show us kind of the experiment decision framework in action, some of the settings we can configure, and then what it really looks like. Yeah.
So one quick thing to add on there is it is really, there are still going to be cases where it's like, hey, what do I do now? So we have that kind of built in to kind of say, hey, this is a call out, like you need to discuss it with your team, because experimentation does get messy. And we'll talk about that a little bit, but this should help reduce friction overall once you've got it set up. So I'm just going to jump into an experiment here to kind of show what it looks like when things are up and running. But in this instance, we have the demo experiment, but we have an experiment where we have our goal metric here is the average user revenue. And we can see here that this experiment is drastically decreasing the average user revenue. So in this case, it's pretty simple. In your case, you'd want to roll back. We kind of explain that up here. We have a call out. We help you when you make a decision, make the quote unquote right decision in this instance. So this is a clear case, but it will help in also kind of more edge cases. But this is kind of what the EDF renders to you on that experiment page to help you make the right decision when you're in these contexts. In this case, it might be clear.
Yeah, and just to kind of call it out. So this box at the top where it says rollback now, this is really like showcasing or surfacing that experiment decision framework.
That's right.
Decision. And so, so we have here, it says rollback now. It tells you the variation rollback and then the reasons to do so.
Yeah, exactly. And these reasons are going to be configurable. So there's a set of logical rules that you're going to be able to set up to choose when something should be rolled back. And I'll go over that in a second, but we kind of explain it here in this instance. And then, the other part of it is we also kind of have this badge up here to tell you that this experiment is in this status. And so then when you go to make a decision, we're kind of pre-filling in the right decision for you. And again, putting that context here so that it's just easier for you to kind of make the right call at the right time. So the other way that this surfaces is when you're at your kind of experiments list view, you can kind of see the different statuses for some of your experiments over here. on the right-hand side.
Yeah, so there's rollback now, and then we can see ship now, ready for review, giving a nice high-level overview of those statuses.
Right. So ready for review is that status I was talking about earlier, where it's, your decision criteria maybe hasn't been leading you to a clear winner or whatnot. And so this is one where you actually probably want to take it to your team, make a decision as a group. Right. So how do you kind of get your experiment into this state? Well, the experiment decision framework basically is comprised of two distinct components. The first is the decision criteria. These are actually what causes you to get a decision based on your metrics values, and then the target minimum detectable effects on your metrics, which is essentially the amount of precision or data you want in your experiment. So I'm going to show you kind of how those two get set up and how they work and how they end up entering into your experiment calculations to get you to that decision point. So under the general settings, we've put the decision framework settings under this experiment settings tab. And as you can see down here, once you enable this for our pro and enterprise customers, you'll be able to set a few different settings. The first is the minimum experiment runtime. This is a number that you can configure where we won't render a decision before a certain amount of time has elapsed. And this is, essential in some cases where you just want to be sure you run every experiment for 3 days or at least 7 days to make sure you get a full week's worth of data, for example, especially if you have strong day of the week kind of effects. But then you also see down here that we have these decision criteria. There's two kind of that come out of the box. One is the clear signals decision criteria, which is basically ship only when there's a clear winner and no guardrail failures. And we have a second one, which is a kind of do no harm principle, which is basically ship so long as nothing is failing. So this is a much kind of weaker standard, but it can be really helpful in cases where your goal is to move forward, develop a new tool without develop a new feature, or a new UI without introducing any regressions in your data, but you don't want to wait so long to make sure everything is moving, every individual change is moving things in a positive direction. So how do these actually look? We can see here, this one's quite straightforward. This one's locked because it's one of our defaults, but basically each decision criteria, you can give it a name, you can write a description that's helpful for your organization to understand what it's actually doing. And then you have a series of rules which help Growthbook understand what to do with your experiment results. So in this case, if none of your goal metrics are stat sig in the bad direction and no guardrails are stat sig in the bad direction, then ship. Otherwise, roll back. And so once your experiment has reached enough precision, which is what I'll talk about next, you end up kind of evaluating these rules in order, and you can create your own custom one with any kind of set of configuration. So maybe you want at least one goal metric to be stat sig good, but no goals to be stat sig bad. So basically, you just want some positive signal, but you don't want your other two goals to be going down, for example. So this is a way to kind of compose complex rules that your organization has derived for your shipping criteria.
What I like about that is that you get the power of an automated kind of system telling you, the recommendation, but you can really configure it to the purposes of your business.
Right. So we have this standard clear signals one, which is, all of your goals are in the right direction. None of your guardrails are failing, then ship. If any guardrails are failing, and then roll back. If any of your goals are bad and none of your goals are good, so there's some negative signal, no positive signal, then also roll back. Otherwise, we're in this kind of ambiguous situation. Maybe some are up, some are down. Maybe there's some mixed evidence. So in those instances, we send it to this review status. So yeah, you can kind of pick the one that you want as your default, and you can add custom ones and make those your default. You can also set these at the experiment level, which I'll show a little bit.
Real basic kind of question, or just to kind of illustrate this a little bit more. What would be a typical or an illustrative goal metric versus a guardrail metric?
Sure. Yeah. So a good goal metric, would be something like a conversion rate or a purchase rate or user revenue. The thing that really is the bottom line for your business that you're trying to drive forward. And then maybe if you're experimenting in some e-commerce site in your e-commerce context, you're trying to drive those conversions up. A guardrail could be something, I don't know exactly in the e-commerce context, but in the tech context, it could be something like an error rate, something like that, where your goal isn't necessarily to reduce errors with this this feature, but you want to make sure you're not introducing something that's causing a whole bunch of problems with database requests or something like that. So your goal isn't to improve those guardrails, it's just to make sure you're not harming them. So I think that would be an example.
Cool. I think that was probably clear, but just to give everyone a concrete example of what these sorts of things are.
Yeah. And you can, exactly. And the reason that's important is you can kind of have different rules based on goal metrics versus your guardrail metrics. And they can kind of have different trade-offs based on what exactly your organization is doing to prioritize in a given experiment. So this is how we look at your results and render a decision. We're going to render a decision, one, if you use the sequential engine as soon as one of these situations is reached, because our sequential engine controls for the false positive rate from peaking, but it comes at a big cost of power. So most of our users will be in this other situation where these decisions are only going to be rendered when there is a very clear result. We have some thresholds you can read about in our docs where it's just such a clear result that it doesn't really matter. The false positive rate isn't really of concern. Or when you've reached the amount of precision in your experiment that you desire to get like good enough results where you're comfortable making decisions. And that's not, again, deciding based on what something's stat sig, but when you have enough data to kind of be clear about what the range of potential results for your experiment are. In Growthbook, we govern this using something called the target minimum detectable effect, or the target MDE. This is kind of the default for your metrics when you create them, but this is customizable at the metric level as well as at the experiment metric level. So if you have a particular precision goal, you can set that there as well. A lot of times people will do power analyses and say that they'll want to detect a 5% lift, and that's going to take them 4 weeks. So that 5% lift is what you want to put as your target MDE for an experiment. And basically what that's saying is once my experiment's confidence intervals are small enough to get to that 5% lift, if it existed, then I'm ready to call my experiment. And that's what we'll use to determine two different things. One, how much longer do we think you'll need to run your experiment for to get this precision? And two, if we're ready to make a decision, we then use those decision criteria on your experiment. I can show this a little bit in action on an experiment.
Can I ask you a question real quick about this?
Sure.
So we have a suggested default of 10%, but is this something that could change kind of depending on what sort of metric you're looking at? Or
for sure.
How do you think about this?
For sure. Yeah, we have some pretty good guidance, I think, in our docs. And I think basically this is the kind of thing that you get more intuition with as you start experimenting a little bit more about what the right values are. And you can use our power calculator to kind of use your data to estimate what is a reasonable one for you. Like how much data, if you only have 5 users or whatnot, then getting a really small lift is going to be hard to detect.
Right.
So
that's also something that's just, I'm not a data scientist, but could be counterintuitive so the larger the minimum detectable effect is easier to do, right? This is a smaller one.
Yes, that is a little counterintuitive. You're right, but basically, this is the smallest effect that you want to be able to reliably detect. So, if it's 100%, that means that you're not really going to have enough data to find it if it was only a 5% lift. You're not going to be able to find it if it was a 10% lift, for example. If you picked a 1% target minimum detectable effect, then you have to collect enough data where if the true effect was only 1%, that you're able to find it reliably. And so that's going to require a lot of users. So actually, for some of our own experimentation, because we're a business-to-business software as a service company, we don't have that many units. We have to use slightly larger target minimum detectable effects than, say, really, really large company that has thousands of users entering every day who are doing some behavior pretty regularly. And so I think you'll get more intuition with this as you start to experiment. So I would consider leaving it at the default or setting it to a slightly higher number and then kind of seeing what your experiments end up actually looking like going forward. So how the target MDE actually influences an experiment results is we can see this sample experiment here called homepage nav iOS. It's an example experiment. We've got 3 variations, a control, and these 2 test variations here, variation 1, variation 2. Now, we've said this is ready for review in this instance because we have a target MDE that is set to very large. So in this instance, even though the confidence intervals here range from negative 60, we're saying, you know what, you've actually told us that you don't need that much precision to make a decision in an experiment. So in this instance, it's ready for review. You got to make a decision with your stakeholders. If we change it from 10,000 to a much more reasonable number, let's say 60, maybe that's the target MDE for us. In those instances, because you can see here, this range of this confidence interval goes from negative 60 to 60, we're not going to have enough data. It's going to say that it's not going to render a decision for you. And it's going to instead, tell you to keep running the experiment for some period of time so that you can get to that tighter confidence interval. So again, you can see here, 60%. If the true effect was 60%, this range of this confidence interval goes from negative 60 to 60. So it's 120 percentage points wide. So it wouldn't actually get you to that level of precision that you're looking for. And so it's not ready to make a decision in that instance.
That's cool. Can you go back to that overview page? So just to show that this is where you could change that number, the target E, for your experiment. And then this is also something you can configure when you're setting it up and that will impact or override your default you've set in the settings.
So just to go over the settings briefly, you have those defaults that are set under your general settings. At the metric level, you can set a default for a metric if you know percent for a given metric. But then in the context of an experiment, you can go to this overview page, and under the analysis settings, you'll both be able to change the decision criteria that you want to use for your experiment, as well as override the metric default that you want to use. The metric default target MDE. So that if you turn off the override, it returns to the default, which for this one I've set to 1,000 for illustrative purposes. Yep.
That's cool. So yeah, you can really have your defaults kind of out of the box, ready to go, but then also you can really customize it on a per experiment basis, which is nice.
Yeah. And definitely a lot of our experimenters that use Growthbook are doing a power analysis, understanding what their goal MDE is for an experiment, and then you'd be able to plug that in here, set it as your target, and then we'd be able to estimate the days remaining for this experiment and then render a decision when it had reached that goal.
Nice. So you mentioned days left to reach power, but what happens if it's like I have 100 days left or a really large number? What can I do, or how should I address that?
Yeah, so there are some instances when you basically have what's called an underpowered test. You might just not have enough traffic or enough data to get a result in a reasonable amount of time. In those instances, we'll say something like this, where it's going to take, in this instance, 6,239 more days to collect enough data. So what do you do in this instance? Hopefully this number would be smaller and you could just wait the requisite amount of time. But if that's not the case, if it is this large, then you're basically in a situation where you are not going to have enough data to reach that goal. This is normally the case when you've set a too ambitious target MDE. You probably are running an experiment where you won't have enough data to get the precision that you've set up front. So there's a couple of different things that you can do in this situation. One is there a way to run this experiment with more traffic? Set to only show 5% of users? Can you increase that to 100% and do a 50-50 kind of test? If you have 4 or 5 variations, that's going to split your traffic among all those variations and make it harder to tell between them. So can you restart your experiment with only 2 or 3 variations? And then lastly, I would say just evaluate whether or not you're experimenting in a situation where you actually are setting those values to the right numbers. If it is difficult to get, say, a 10% lift that's detectable in the context that you're used to, then not in necessarily the context of an individual experiment, but you should consider whether maybe the default for these metrics for you should be something more like 30 or 40% or some higher value. I don't recommend kind of tweaking this till you get an answer. That's not very good practice, but it maybe is informing maybe what your organization's priorities and informing what it is that you're actually able to detect. And you don't want to be setting your goals towards something that you're never really going to be able to achieve with the amount of traffic you have. So this can provide you some feedback in that way. Another option, actually, I should mention, is sometimes it's very hard to detect effects on very rare events. So if you have a long-term or downstream conversion rate type metric or outcome that only a few users are doing, that's going to have high variance. And it's going to be really hard to detect movements on those rare events. So maybe your goal metric should be something that is higher upstream, closer to the experiment, that is more influenceable by your experiment. You can still track that downstream metric, but maybe it shouldn't be as your key goal that's determining when you're ready to make a decision for your experiment.
That's really helpful advice for the experiment decision framework. Is there any kind of things that you want to talk about or mention in regards to it?
I would say that the main thing here is providing a tool for people who want to reduce friction downstream for their experimenters. So folks that are looking for ways to basically, when they come to an experiment, know what to do next. You might have to do a little bit of work to understand, well, what is the kind of precision that I can actually estimate, like we talked about, do some power calculations, and think about as an org, wait, do I actually want to only ship if it's a clear winner, or am I happy shipping as long as it's not hurting? So it forces you to discuss and figure out answers to these questions. But then once you have answers, it reduces friction for experimenting going forward. People can, individual experimenters go out there and make decisions with confidence. So I think that's kind of the high level goal here. And I hope that, we help people achieve that.
Yeah. So it's not just about the stats. It's also about the culture and kind of trying to bring those both together with our new experiment decision framework. Well, thank you very much, Luke, for joining me and talking about it. It was really helpful to just kind of see you go through it and about how you think about it. I think it'll be very helpful to our users who, if you're trying this out, the experiment decision framework, let us know how it goes. You can join us in our Slack community, talk about it, ask questions. We're there all the time answering things. But until the next one, happy experimenting.